Vale, vale. Buenos días, bienvenidos y gracias por asistir a esta sesión de Construyendo Pipelines Reactivos totalmente en español. Bromeando. Okay. I have actually presented a version of this talk entirely in Spanish, but I've since refactored it, and I think since the organizers had heard me present in Spanish before, they asked me to present in English. I don't know why. I'm still learning English too, but I have several years head start on it. So anyway, I'm told we only have 40 minutes today, which is tight. So I'm going to move through things quickly. I try not to speak too quickly, because I know what that's like as a non-native speaker trying to understand, but I do want to proceed at a pretty rapid pace. So if you have any questions, comments, feedback, by all means, please let me know after the fact. I have a feeling I'm going to take the entire time. But also, since I have just refactored this, I've given this talk twice in the last week, a variant of it, and I'm always looking to refine and better. I felt like the talk I gave before, the version before, was good. I got good feedback, but I felt it wasn't tied together as well in different pieces, so I refactored and I feel much happier with it. But again, I value your opinion, so please let me know. So anyway, just to launch right in. So whose boss has come to them and said, hey, you did a great job last year. I'd like to double your budget and ask you to slow down a little. Yeah, that never happens. If you're in an organization like that, please let me know, because I'd like to do a case study on your organization. Usually we're asked to do more with less, or maybe, if we're lucky, more with the same. We're never asked to do less with more. We're always looking to extract more value from the resources that we have. So in short, why are we here? I'm going to be discussing a few things, and again, very quickly, sadly, I actually like to kind of talk about this stuff at length, so if you want to continue the conversation, please do see me afterward. But very quickly, we're going to discuss kind of traditional approaches to scaling, and then what happens when we hit the limits of those traditional approaches. And then, because I'm a very physical person, and I think as developers we typically are, it's good to see it in action, it's good to see how it works, so I'll be coding through all of this, an example of this, live coding, so we can kind of see it in action, see how it's put to use. So who am I? I have authored several blogs and blog posts. I guess I should start with my name, right? Oops. Mark Heckler, pleased to meet you. Mucho gusto. I have authored several blogs and blog posts. I've co-authored a couple of books. I've contributed content and code to several other books, a few of which even recognized my contributions. That was nice. I am an architect and developer, and as most of you might surmise from the next point, where most of my expertise has been won, it's been in the Java ecosystem, some Groovy, a lot of Java, some Kotlin. I love Kotlin. Today I'll be sticking with Java, but I do talks in Kotlin as well, so if you're one of my people, come see me. I am a Java champion, Java 1 Rockstar, Groundbreaker Ambassador, a few other awards and honors which I deeply appreciate, but still mean I have to buy my own coffee, so go figure. I know I should work on that, right? I am a professional problem solver. That's not my official title, it's just what I do, right? As do you, that's why we're here. I am officially a Spring developer and advocate. I commit code to Spring projects, as well as getting to talk about the technology, which is two of my favorite things after my wife, right? Love my wife most, this being recorded. But I love to code and I love to talk, so combining those two gets me the best of all worlds. I am el único creador y curador de Spring Noticias en Español. If you are a Spanish speaker, if you have resources, if you write blog posts, create videos, write a book, whatever, let me amplify your voice. I saw something a couple years ago that made me a little sad. Spanish is the #2 most spoken language in the world, and yet there was no kind of single point of sharing for Spring and Java and Kotlin resources and things like that, Gradle, Maven, what have you. And I thought, hey, I can do something about that. I can contribute my little efforts to maybe helping amplify your voice and sharing that information among the greater Spanish-speaking, Spring-based or not Java community. So reach out to me, help you, help the community. So with that, I also have a new book coming out. This is just a mock-up. This is not official. They'll probably kill me when they see this. I was looking for a monkey running, because up and running, this is the closest I could find in the fake book cover, the parody book cover generator. But I will be creating a real book. I just signed the contract. The ink is still wet. The virtual ink is still wet. So over the next year, I'll be putting that together. Second half of next year, Spring Boot up and running. Check it out. Hopefully it'll be good. So for starters, what do we do to, and I need to make sure I don't run too far over the time because they promise us like coffee and cookies, right? But for starters, what do we do to scale? Many of us have or do work with monoliths, right? And monoliths are fine. They do the job in most cases, but they're not brilliant at scaling because typically monoliths employ a lot of different capabilities. And when you scale a monolith, you basically pick up the monolith and duplicate it, right? So setting aside contention issues and things like that, taking something that was meant to be the only one of its kind and making it one of many. But we also see that that's not very effective in terms of scaling. Because when you have within a monolith, you'll have multiple capabilities, a few of which will be used a lot, a few of which will be hardly used at all, and many in the middle, which are used some, right? But when you scale the monolith, you duplicate all of that. So you're bringing along the baggage, if you will. It slows development, it slows deployment. It also isn't terribly effective at scaling. So when we start thinking about scaling and we have a monolith, we start thinking about teasing out certain capabilities, right? The capabilities that really need to scale dramatically. Maybe they're more volatile bits of functionality. Maybe they just need to scale more dramatically than other parts of the monolith. So we look at microservices, and that gets us a certain ways, right? But typically when we start off with microservices, we start with an HTTP-based API, like a REST API. And what we see is that a microservice doesn't tease out by itself. Typically, to provide a capability, we have 2 or 3 or 5 microservices which work together to provide that. The problem is, of course, that once we do that, we see that maybe a couple of microservices are rather tightly tied. They're coupled as well, because let's say service A has to deal with service B and make requests of it to come back and provide that capability. What we see then is that they're rather closely tied in terms of scaling and communication, because they both have to be online and available at the same time. They both have to scale fairly linearly together to handle the same number of requests and responses. So then we start looking at things like a messaging platform, which allows you to decouple those two. In this case, I always typically boil examples down to the simplest possible example and then build it back up, so bear with me. But if we have service A and service B, we can temporarily and locationally decouple those using a messaging platform. Messaging platforms allow you to, if you're a producing consumer or producing service, to push a message into the pipeline. And I do try to stay at that generic terminology because that way we don't get Kafka folks angry at Rabbit folks and so on and so forth. But you push a message into the pipeline, and perhaps the consuming service, service B, isn't even online at that point in time. And when it does come online, perhaps the producing service is not online at that point in time. So temporally, they're decoupled. They're also locationally decoupled because service B doesn't know or care where the message came from. It just knows it has a message to consume. There are many examples of messaging platforms. Too many to go into in a single talk, but I like to concentrate on what I consider to be the top 5. RabbitMQ and Kafka top the list, of course. Been around for a long time, super scalable, very well proven in very large production environments. You have things from all the major cloud providers, and I typically focus on one from each, kind of the first among their peers. So things like Amazon Kinesis, Microsoft Azure Event Hubs, Google's Cloud Pub Sub, things like that. But again, those 3, the Amazon, Azure, and Google entries are not open source. Maybe that's important to you, maybe it's not, something to consider. RabbitMQ, Kafka are provided by both the creators and guides, sponsors, if you will, of said technologies. They're also provided by numerous cloud platforms. You can run them in-house, what have you. They're also open source. So I consider those 2 to be the first among even those peers. But again, your mileage may vary. It'd be great if you could focus and choose just a single cloud or messaging provider. That would be wonderful. But even if you standardized on one within your organization, if your organization has partners, commercial partners, they may have standardized on something else. Or perhaps your company acquires another company or is acquired by another company. If you're standardized on Rabbit, they're standardized on Kafka, then what? What do you do? Most times, as developers, we care about a couple things. Pushing messages into a pipeline and pulling messages from a pipeline. And of course, that doesn't mean that we don't ever need to tweak the settings, so to speak. But most cases, that 80 to 90% of use cases, we want to be able to distribute messages via some pattern and receive them. and process them. Spring Cloud Stream, again, 100% open source, Spring project out on GitHub, but it allows you to do that and elevate your concerns so you can focus on the business problem at hand. Should you still need to tweak the levers underneath, you can. Don't have to in most cases. And that is made possible by binders. So when you use Spring Cloud Stream, you have a binder to Rabbit or to Kafka or Kinesis or what have you. Binders are either maintained by the Spring team, things like Rabbit, Kafka, and Kinesis, or maintained by our vendor partners like Microsoft for the Azure Event Hubs binder and Google for its Cloud Pub Sub binder. So it's all out there. And we also have community binders too. If you're using something that's maybe not part of the mainstream, but still well supported, it's out there as well. So again, because time is limited, I'm going to roll right in. The first time I gave the talk in terms of coding, I kind of skipped over a visual example, and I think it's useful to understand, when you see the kind of context. So at a very high level, Spring Cloud Stream provides you 3 interfaces by default out of the box: a source, a processor, and a sink. A source is just the thing that produces values, right? It creates values, pushes them into some kind of a pipeline. A sink is just what consumes those values at the other end. End of line. I'm done. This message is over. Been nice having you. In between, you may have one or more processors. A processor just takes a value, manipulates it in some way, and passes it on. And you can mix and match these in various different patterns pretty effectively. But if for whatever reason the built-in interfaces don't solve your needs, you can create your own. You just create an interface with one or more message or subscribable channels for incoming and one or more message channels for outgoing. And you can tweak that, again, infinitely, pretty much. So if you've done all that and you're still working in imperative Java and you've hit the wall, now what? Perhaps you're wildly successful, your app's gone crazy. How do you extend your capabilities even further? The traditional approach in Java works really well up until you maximize your thread count, right? When you have a thread pool for, let's say, n threads, and you have up to n requests, your performance profile is fairly flat. I mean, it kind of, I guess, goes this way, right? It kind of creeps upward slightly, but it does pretty well until you hit that n+1 request. Because at that point, something stops. It waits, it blocks, right? And it's waiting for one of the other threads to be freed up. And out of those n threads, guess what they're doing most of the time? Nothing. They're blocking too because they're waiting for a response from another service or a database call or what have you. So it's easier to reason about that mechanism, that method of scaling, but it's not terribly effective, right? So then we need to look at things like asynchronicity. Reactive programming switches to an asynchronous approach. And I'm kind of checking my notes because I'm trying to stay really on target because otherwise I monologue, and I know our time is short. So that can scale like mad, right? An asynchronous approach, a reactive approach allows you to insert an event loop, and there is a difference, and I'll get to that momentarily, but this allows each service to go wider. There are some performance gains to be realized as well. I don't focus on those as much because that's not the primary focus, but if you can parallelize your workload, it's quite dramatic at times, right? Because in an imperative approach, in a blocking approach, if you have 4 requests that each take a minimum of ½ second, the minimum amount of time for service B to respond to service A is going to be 2 seconds, right? ½ second times 4. But if you can parallelize those, what's the minimum response time for service B to a request from service A? Minimum ½ second. So you go from a minimum of 2 seconds to a minimum of ½ second. So that's a 400% increase in performance. Not across the board, depends on your workload, but again, it's something interesting to keep in mind. Project Reactor is an implementation of the Reactive Streams initiative. There are other implementations. Reactor just happens to be the best. Okay, well, come on. Yeah, it's all right. I mean, I do think it's the best. I'm very biased, I will admit that. But there are several other companies like Facebook and Microsoft and others who have standardized on Reactor because it kind of makes sense. It's kind of out there in the forefront. But we all play along together, and based on the Reactive Streams initiative and the TCK, we can validate and verify that we do play well together. So again, you have options. If it would integrate with messaging platforms, all the better, so we can capture our gains from earlier and extend them, right? At this point, some folks say, well, what is reactive programming? I love this quote by one of our Reactor team members, Ross Stoyanchev, so I use it all the time, much to his chagrin. But Rawson said that reactive programming is about non-blocking event-driven applications that scale with a small number of threads with back pressures and key ingredient that aims to ensure producers do not overwhelm consumers. If you just look at the first part of that, you could still be talking about asynchronous programming. Asynchronous programming has a few problems. The number 1 and 2 of which, in my mind, are legibility, right? Anyone dealt with asynchronous programming? You heard of the term callback hell? I'm convinced that was coined by an optimist. It's worse than that, right? It's not very readable when you get a sophisticated, nesting of callbacks, right? And I use the term sophisticated kind of loosely here. But the other problem is, in a purely asynchronous system, what happens when a slow consumer says, give me what you have, to a producer that produces a lot of values at once? Typically, that slow consumer just kind of falls over, right? That's a problem. With reactive programming, a slow consumer can say, look, I can only handle 10 values at a time, so give me 10. And when I'm done with that, I'll request 10 more, or 50, or 100, or whatever. But that allows that slower consumer to kind of gate the amount of data it gets and can process at any given point in time. Doesn't change the fact that you have a producer which may be producing 1,000 values per second, but what it allows you to do is shift to an area of your control, because you may not have control over an iPhone client 2 countries away, but you do have control over your cloud service. And if you have a slow client, you can determine how best to keep that client alive, how best to keep it in the game. So you can buffer, you can sample your output going to that slower consumer. If it's just a dashboard, you don't care about what happened 3 months or 3 years ago, you can just drop all the intervening values between requests. But the power is back in your hands, which is kind of nice, right? Okay, much more to be said, don't have time. So the Reactive Streams API is very simple. There are 4 interfaces, right? So you have to either build or use an implementation. You have a publisher, which produces values of type T. You have a subscriber, which consumes those values. You have a subscription, which is the contract entered into between subscriber and publisher. And then you have a processor, which incorporates both the interfaces of subscriber and publisher, because a processor transforms. It takes a value, manipulates it, passes it on. So that's pretty good, right? The Reactive Streams initiative also, as I mentioned, has a TC case. You can verify how compliant you are, where you fall short, how to fix it. But these are interfaces, so there's a great amount of sophistication that goes into creating a useful library that builds on these. Within Reactor, we actually specialize the publisher, because just like in plain Java, if you have a return value from a method, you can return an object of type T, for instance. You can also return an iterable of type T, so some kind of collection, small collection, large collection. Same thing here with a publisher. There are going to be times it's useful to return 0 or 1 value, a mono, as we call it. There are going to be times you'll have a collection, maybe an indeterminate number of items over an indefinite amount of time, and that is a flux. That's where we get the term for Spring Web Flux, which is built around Project Reactor. So, there we go. I was going to say it took a little while to advance. The cool thing is this ties in really nicely with Spring Cloud Stream and streaming with messaging platforms. So I mentioned earlier you have a source, sink, and processor. The publisher roughly corresponds with a source. It's the thing that produces values. The sink corresponds with a subscriber in Reactive Stream speak. The subscription is actually, the role of a subscription is fulfilled by the pipeline connecting the two, the subscriber and the publisher, and a processor correlates to a processor, right? So that makes things nice and simple. So let's code. I did pretty well on time, I think, so that's not bad. So we have until 10 after, 20 minutes. We can do this. Okay, so does anyone recognize this guy? All right, Maurice Moss from the IT crowd. Those of you who did not raise your hands, fortunately we have a weekend coming up. Stream this. It's on Netflix called the IT crowd. It's a little dated now, but it's still so funny. It's about our lives, right? So this is one of the main characters, Maurice Moss, my personal hero. So let's start with this. So I'm going to exit that, and let's see. We'll go back to here, and I need to switch where you can see this. Mirror. Oh, that's much better. Okay, so this, was anyone here for my colleague, my teammate Josh's presentation yesterday? So you're well acquainted with this, right? This is the Spring Initializer. This is dark mode. This is my personal favorite, but if you're not a dark mode fan, you can go back to a light UI. That's fine too. I like dark mode. I live in a cave, but that's fine. We'll make this a little brighter today. So I'm going to start off here creating a few different microservices. And you don't have to start with this. If you want to hand code everything, by all means you can. Not the most productive use of your time, I must say, but you can do it. You can also curl this, HTTP this. You can use this from within your IDE. it's all good. So whatever you want to do, I just like to come here because it's a really nice jumping off point, right? So you have options here. You can actually explore a lot more options, which I won't do at this point. But you can generate your project. This doesn't generate code other than your main application class, main method. But what it does do is allow you to choose your dependencies, your starters, which bundle in capabilities that you're going to use for various different applications. And even here you have choices, right? So it will allow you to create a Maven project, Maven-based project, or a Gradle-based project. If you're like to work with Maven, you can create that Maven project, and that's great. If you're a hipster, you can also generate a Gradle project. I put my hoodie in my bag, so I'm just going to stay with Maven. I'm not feeling the hipster this morning, but that's fine. Whatever makes you happy, that's good. You can also create Java, Kotlin, or Groovy. Again, a lot of times I use Kotlin, and actually, now that I think about it, when I use Kotlin, I typically use Gradle. When I use Java, I typically use Maven. I don't know, habits, I guess. But today we're going to stay with Maven and Java. I'm going to use the current version of Spring Boot 2.1.8, and I'm going to change this to Los Heckler, because I can, and I'm going to create 3 different microservices, again, starting small and building out, one for each of our source, processor, and sink, and we'll go through and show the capabilities of each. So I'm going to choose some dependencies here. So I'm going to bring in Reactive Web. This gets me my reactive foundation for web-based applications, and Netty. Those of you who are used to Spring MVC know that Tomcat is the default, but you can swap that engine out. Same thing here, Netty's the default for reactive apps. You can swap it out, but Netty's solid, so I typically just stay with that. And it screams, right? In a good way. So I'm going to also choose Reactive Cloud Stream. Again, this allows you, as it says, to create messaging microservices with Spring Cloud Stream. It does require a binder because the idea of when you create a Spring Cloud Stream application, Spring Boot's auto-config says, look, you have Spring Cloud Stream capability here. You have perhaps a Rabbit driver here, but you don't have a binder. You need a binder so you can talk to Rabbit or Kafka or what have you. So it's telling us that. I'm going to bring in RabbitMQ because I like Rabbit. Choose whatever you want to, it's all good. And then I'm going to bring in Lombok because I'm a lazy developer. Lazy good, not lazy bad. Lombok allows me to eliminate a lot of boilerplate, right? If you're using Kotlin, Lombok's irrelevant. And I don't typically recommend Lombok in production environments, but do what makes you happy. And it does work exceedingly well for demos. So I'm going to go ahead and generate my source project. And just in the interest of time, because again, we are pretty tight on time here, and I want to make sure I get through it all, I'm going to create my processor project at the same time, and then also my sync project, and we'll just go from there. And that way I can just quickly open them all in the same spot. Hello. Where are you? There we go. Okay, so there's my source, and I'm just going to open that in my favorite IDE, NetBeans. Otra vez bromeando. Okay, kidding again. I am kidding. I like to pick on my friends. NetBeans is an awesome IDE. It has great Spring Boot support. It really does. And it's a super useful, easy-to-use IDE that still gives you a lot of capabilities. Any NetBeans users here? Yeah, keep doing it. Do what makes you happy, right? Any Eclipse users here? Eclipse is also an IDE, right? Not my favorite. I always kind of equate Eclipse to that like 500 wide Swiss Army knife with all the blades. You know there's a way to do it, you just can't figure out how, right? Can't find it. But we do have a build of Spring Tool Suite, Eclipse called Spring Tool Suite, which has great cloud deployment capabilities. Every time I see the latest additions to that, I go, oh, that's pretty, that's nice. But I use IntelliJ because I do a lot of Kotlin as well. And the folks who bring you IntelliJ also bring you Kotlin. So as you might imagine, interactions and integrations are sweet. So I'm going to start off here. I'm going to go to my application properties. And this is where you put the kind of sensible defaults for your application startup, or you externalize them in environment, what have you. Again, for a demo, I'm just going to place them here. I'm going to set my server port equal to 0. As a Spring Boot application, it will just look for an available random port and use that so I don't have port conflicts among my apps. That's just for convenience for me here for the demo. And then I'm going to set my bindings. Now, in a Spring Cloud Stream application, well, in particular, this is a source, right? So a source has an output channel. A source produces values. It doesn't consume them. It just produces them. So you have a binding for an output channel. And I'm going to point to a destination I'm just going to call processor, right? But again, you can call it anything you want. It's just where you're going to send messages. I'm also going to start off by having a function definition, which I won't define just yet. But this is pointing to the new functional interface, API, for Spring Cloud Stream and Spring Cloud Function and some other really cool things that you're going to like going forward in a lot of different ways. So we'll get into that momentarily. I'm going to go to my application class and start coding. Now, they always tell you, life advice, right? Do what you love. And I love coffee. So most of the time, my applications, my demos revolve around coffee. And that's great, but once in a while in an event, I'll do multiple talks, and I don't want to over-caffeinate anyone. So I thought about what else could I talk about that I know about at least. And those of you who follow me on Twitter know that I travel quite a lot, right? By the way, if you don't follow me on Twitter, MKHeck, why not, right? So please do, but that's where I make all the announcements and share fun stuff and the occasional cat video and what have you. But I do travel quite a lot because that way I get to come here and talk to you, and that's kind of the highlight of my life here. So, and that's not sad, please. Don't anybody think that's sad, except for the travel experience. The travel experience is kind of sad, but getting there, that's so worth it. So I thought, how can I do something to contribute to bettering the airline experience for those of us who travel a lot? Because there should be some way to better that experience, right? So I'm thinking, let's create a series of applications, a series of services, which can process you from the time that you check in as a passenger all the way to the time that you're stuffed in the overhead bin in an aircraft. So once you bought a ticket, you're still not a passenger, you're just a consumer. You've bought the ticket, you're a customer for the airlines. But once you arrive at the airport, you're officially a passenger, right? I'm going to use Lombok, so I'm going to annotate this as that value. That tells Lombok to make it a data class for starters, getters, setters, equals, hash code, two-string methods, all provided for me. And then also the constructor, an all-argument constructor, so I can make this effectively a closed data class, or as close as you're going to get using Java. So I'm going to start off, again, fairly simple, private final string. I'm going to need an ID and a name, and that gets us for our domain for this, just to start off. Now, this is my source, so I can either manually create the values, the passengers, and push them into the pipeline, which sounds like a lot of work. Again, I'm a lazy developer, so I'm just going to create something to automate this for me. So I'm going to create a passenger generator, right? And I'm going to, let's see, I'm going to create an array of strings. There we go. Come on. Come on, IntelliJ. There we go. Okay. And we'll call this names. And this will be arrays.asList. And let's have some names to plug in here. So Arturo, right? And let's see, Carla. Let's see, Eugenio. Spelling is tough. Gina, yeah. Let's see, Ignacio, and Katarina. And because I always like to use myself as the bad example, right? I don't like to pick on anybody because then they'll go, why did you do that to me? And I understand that, right? Because I suffer through this a lot myself, so I'll do it to myself. It's fine. So I'm also going to, back that up. So I'm going to insert a little bit of randomness, because random is fun, so new random. And let's create this. So we're going to generate a passenger. We'll call the method generate, return new passenger. I'm going to use UUID to create a UUID. An ID, excuse me, and then I'm going to just grab from names. I'm going to get, not get class, I just want to get, no. Let's see, yeah, list. I want a list. That's much better. Okay, that makes me happy. Okay, so names.get. Sometimes I get to talking and coding, and who knows what comes out. So then we're going to generate a random number bounded by the number of names we have, so size, and that's sufficient. So that will get the job done in terms of generating names. That will generate our passengers. But now we need to push them into the pipeline. So I'm going to enable binding to our source, right? And then this will be our desk agent. This all starts when you go either, and of course you can check in online, that's fine, but we'll assume you're going to go to the desk agent, check your bag, whatever, get your boarding pass, and that is the point in which you become a passenger, right? So I'm going to inject our passenger generator, and we'll call that generator. Now, in Spring, you can do, you can auto-wire, do field injection, if you will, but that's evil, basically, because it allows you to create something and assume something is there that may or may not be. So we don't typically do that. We use constructor injection. And I can create a constructor, but again, lazy developer. I'm using Lombok. I'm going to ask Lombok to do that for me with an all-args constructor. With that annotation, Lombok will create a constructor with a parameter for every member variable. In this case, my passenger generator, so life's good. At this point, I want to create a bean. And if you start thinking about this at a higher level, wow, we can do this, 10 minutes, no problem. At some point, if you start thinking about a source, a processor, and a sink at a higher level, and this is where the tie-in with Spring Cloud Function comes, you really are talking about a supplier in terms of a source, right? And a function is a processor, a transformer in terms of a processor, and then a consumer is your sink. So we're going to do that. We're going to create a supplier. And we could say a supplier of passenger, but we don't want to deal with one at a time. We want to deal with a flux of passengers. So let's kick this up a notch. Let's see if I can type here. There we go. And we'll say this is check-in. So we will, of course, this is a functional interface with a single abstract method. Since Java 8, we've been able to create a Lambda and provide that as our implementation of said abstract method. So we're going to return, and this is a supplier. So let's see, we'll create a flux at an interval of 1 per second, and we'll map each of those long values that comes out of that, and we'll ask our generator to, on each pulse, to generate a value. Now that's sufficient, that's okay, but as a good practice, what we should do is define what happens if you have a very slow consumer. Now granted, it would have to be a very slow consumer to not keep up with 1 per second, but again, we should define what happens on back pressure. So you can define buffers, max sizes, you can define what happens if there is a buffer overflow and what have you. I'm just going to drop the intervening values for the time being, but again, your use case may vary. So now we just take our bean name, add that to our function definition, and we're off. Now I'm going to go ahead and create our processor and sync, and then let's kick off the party. So we go to our processor, and application.properties, server port 0, and I'm going to just close that down, give us a little more screen real estate. Spring Cloud Stream bindings. In this case, a processor has an input channel, right, and an output channel. So our input channel is processor, right? That's where we were pushing the values from our source. I'm also going to define a group. If you don't define a group, each additional processor or sink that comes online, it gets a copy of the same message, so it creates a fan-out pattern, which if you want to fan out, that's great. If you want to scale, that's not great. So you add them to the same group so they take turns, and that way you can scale out at each level. I'm going to add that to the same group. We're going to define our binding for our output, and our destination here we'll just call sync, Spring Cloud Stream function definition we'll come back to once we have a function. Now, this is our processor, so we know right off the top it's going to be receiving passengers from our source, right? And once again, string ID and name. And of course, we want to transform these. This is a processor after all. So we're going to create a flying passenger. This is what you are once you survive security, right? And you get to the gate. So once again, we have string ID and name, if typing is still a thing. And then, of course, we want to, as our airline of choice, we want to be able to surprise and delight our customers, right? So we should have a status associated with each of our flying passengers. So we'll call this status. And we would say that all of our customers are valued, all of our passengers are valued, maybe not on my airline, but on yours certainly. And then occasionally we'll choose one passenger out of every so many to call a premium customer, and maybe we'll kick them a little less. Or maybe we'll give them an extra bag of dry pretzels, or what have you. But we should recognize them in some way. So we want to add that, private final status, and now we need to we need to bind to our processor. Processor.class, I can't type. Okay, so this will be our gate agent. And I'm going to inject a bit of randomness here as well, because again, random is fun. New random, and here we go. So I'm going to create a bean. This will implement a function, right? And we will take in a flux of flying passengers. Oops, Nope, actually in this case, I just want a flux of passengers, because what I'm going to do then is transform that into a flux of flying passengers. And we'll call this board passengers. Okay, so this is a function, return, once again, functional interface, single abstract method. We're going to return this. We're taking in a flux, and we're producing a flux.map. We're going to map each value as they come in, and we're going to take this passenger. I'll just shorten this, and we'll create a new flying passenger. We'll use our passenger's ID. We use our passenger's name, right? And here's where the random part comes in. So we will say 1 out of every 5. So if take a next int of 5, if it equals 0, right? What we want to do is say that this is a premium customer. If not, this is a valued customer. So the other 4 out of 5 will be valued customers, of course, right? So that's sufficient. I just need to go up and take my board passengers bean and put that in for our function definition. Let's go ahead and go create our sync now. There we go. So exciting. I can feel the excitement here, right? I know flying, it's not like you love the flying experience, but you love to be where you finally wind up, right? And this, until they work out that whole Star Trek transporter beam, this is what we're stuck with. So might as well make it the best we can. So I'm going to, again, this is our sync, so it has a binding for an input channel. That's it, right? And this is bound to sync. Once again, for a competing consumer group, we want to add that. And then for our function definition, we'll come back to that momentarily. Go to our application code. And of course, at this point, our processor has converted passengers into flying passengers. So that's all we'll be receiving here. So flying passenger and enum status, valued, and premium, and then private final string ID name. Typing is so hard. The more I hurry, the worse it gets. Status. Perfect. Okay, so now enable binding, and we'll bind to our sync, right? And this will be our flight attendant. It gets even better. A flight attendant. So for our flight attendant, we need to define a bean here, and this is a consumer bean, and we will be consuming a flux of flying passengers, correct? And let's see, we'll say greet passengers. Return, once again, single abstract method, part of a functional interface. So return flux, and we'll take that flux and we'll just subscribe to it, and we'll map it, and we'll just output it so we can see what we're dealing with. And then we'll take our name, plug that in, and off we go. So this will get us started, right? And we've got 5 minutes left, so plenty of time. This is awesome. So we're up and running here. And of course, everything always works in live demos, so no worries there. And we'll do this here on our processor. We'll start that. Wonderful, up and running with that. So let's kick off the party here. Let's start our source, and let's see the data flow. Let's see the messages just go through the pipeline. And I'm going to switch back to my sync. And look at that. So we see we're getting names. We're getting our flying passengers all the way into the plane. And we see that most of them are valued, but occasionally we'll choose to recognize one with a specific premium, right? Again, that extra bag of terrible dry pretzels, maybe, but whatever. So we know that we're at least working. We're getting those values coming through. So I'm going to go back to my source, and I'm just going to stop that for now, because now comes the time that it gives me a chance to kind of show some of the other capabilities. This is good so far. It's much cleaner as an API than Spring Cloud Stream traditionally has been. It's been very verbose, very understandable, but it's less composable, because on a transformer, especially in a processor, you have many things that you can go through to process the changes, right? But it's not as composable, so we broke that out. And made it much more composable and more dynamic. So I'll show you what I mean by that. Because what I was thinking is, there should be some way for frequent flyers to suffer just a little bit less, right? So what I was thinking is that if we maybe add into the process a little bit, add another transformer here. So I'm going to create another bean, and this will be a function. We'll take a flux of flying passengers, because again, that's what we're coming out already from our board passengers bean. And I'm going to convert that to a flux of flying passenger once again. And we'll call this treat mark. I'll be the guinea pig on this. Ideally, what I would love to see is a third status class here, right? Third status, something like guaranteed upgrade. Wouldn't that be nice? Yeah, I always try to model reality, so that's never going to happen, right? This is more what actually happens. So enhanced screening, seat by toilets. That's my life right there. And frequent flyers, anybody else out there a frequent flyer? You know what I'm talking about, right? I mean, you just hope for a break. Maybe the seat next to you will be empty, and instead what they do is shove you back by the toilets. Great ambiance. Okay, so this is kind of what we're dealing with, right? So here's how we would do this. We get a flux coming in, we'd do a flux.map, we'd take our passenger coming in, and we'd do a new flying passenger. We'll use the same passenger's ID. Let's see, ID. We'll take the same passenger's name, and then of course, if the passenger.get name equals ignore case equals mark, again, I'll be the guinea pig, right? So if that happens, what we want to do is assign a value, or we don't want to, but this is what actually happens. This is the value, right? Otherwise, we just take the initial get status coming in and pass it on out, and we leave things as is. So nobody suffers except me. Okay, so I'm going to add this in. If we want to chain these operations, we can do that. We just pipe them. Looks like Linux or Unix, right? So nice. The nice thing about this is you can externalize this into your environment. So if you have an environment variable called spring_cloud_stream_function_definition, you can do blue-greens. You can stop and restart. You can change things over dynamically without rebuilding and retesting your software, which is really, really cool. So you can dynamically compose your pipeline. So I'm going to go ahead and restart this. And then I'm going to go over to my sync, and we're going to change that coming out there. So here we have a third state. Oops, nope. I got to go back over. Just, again, lazy. Close. And we'll grab the super status here, and we'll add that in. Okay, I'm going to restart my sync. And then we'll go back to our source and restart that. And we'll go back to our sync so we can see what happens. And there we see it. Now, will it work? Oh, there it is. There I am. You always know, if you're looking for me on a plane, I'm right by the toilets. Okay, so as sad as that may be to end on, all bad things and good things have to come to an end. So I'm going to go back here. And actually, what I want to do is go back to here and start with that. And we'll wrap up in the nick of time. So if you'd like to check out resources on this, all the code that you saw and more are out here in my GitHub repo in the Building Reactive Pipelines repository in my GitHub account. And if you want to know more about Spring Cloud Stream, the docs are there. They're excellent docs, if I do say so myself. And you can jump off straight to the GitHub page from the link from that so that you can see the whole project yourself. By the way, we do take pull requests. If you have an idea that something isn't working the way you think it should or is missing, ask first in case maybe you're not understanding what it is specifically that's provided or how. But if it's not there, ask if we would like you to work on a pull request. If it's already being worked, that's obviously good to know so you don't waste a lot of time. But if it's not, we love community. We love pull requests. So keep that in mind. Fully open source. Project Reactor's homepage, again, great documentation on how to convert your applications to reactive, how to create new reactive applications. If you want to reach out to me, by all means, please. Email is not the best way, but I am available there. The level best way is on Twitter. If you have questions, comments, or feedback and you want to send them out publicly, just tweet me. If you want to share something privately, my DMs are open, so just send me a direct message. Perfectly happy to hear from you any way you want to communicate. And with that, thanks so much, and enjoy Codemotion Madrid.